What kind of materials can bring you to the moon and back safely? Today, I want to talk to you about the amazing material science challenge of the Artemis 2 mission, and in particular, the little capsule that could, Integrity. Integrity is the name that the crew gave to their spacecraft. That's the part of the Artemis 2 mission that actually goes into space and then has to come back. As you can imagine, it has to survive some pretty tough material situation. It has to be able to operate in the cold of space, but it also has to be able to withstand the heat of re-entry in the atmosphere, up to 2500 Celsius. It has to be very light, so you can actually launch it into space, but still has to be strong enough to, again, withstand the strength of that launch. So how do we do that? Well, NASA's approach has been to work by layers, like an onion. The first layer is going to be what gives it its structure, and in this case, it's an aluminium-lithium alloy, which you can see here. The reason why we use aluminium-lithium alloy is if you look at the periodic table, you can find that aluminium and lithium are pretty much towards the top of the table, which means that they are light. However, when you combine them together, in the metal, there are small impurities that form that we call precipitates, and those precipitates give a lot of strength to that alloy. As a result, it's a very nice compromise between being lightweight and being relatively strong, at least strong enough to withstand the launch. But if you know anything about metals, you know that aluminium melts at pretty low temperatures, and that's what brings us to the second layer, which are thermal tiles. These tiles are going to protect the entire crew throughout the entire mission, including during the re-entry. They are made of alumina, which is aluminium oxide. Wait, I know I just told you that aluminium melts at fairly low temperatures, but its oxide is much more thermally stable, which means it doesn't really react to cold or to heat, really. So that keeps the crew safe. We're done. Not quite. It's strong, it's good with heat, but it's not quite good enough, and we need a final layer. This is the ablative heat shield. Ablative just means that it's meant to be actually consumed. It's sacrificial. It will burn away during the re-entry in the atmosphere. And the way it works is pretty nifty. What happens is that as it burns, it generates a chemical reaction which will expel gases out of the heat shield, and those gases are going to form a protective layer, what we call the boundary layer, which actually prevents direct contact between the spacecraft itself and the very, very hot gases seen during the atmosphere. So the hotter it gets, the more it burns, and the more it creates gases, and the more it protects the spacecraft. And that's it. With all of that, you are able to get your crew safely back onto Earth. Now, I know I gave you a lot of information at once, but don't worry, I devised a very useful little acronym to help you. A stands for aluminium-lithium alloy. A stands for aluminum.